Welcome to another CO2 Monday. I'm your host, Trevor Matthews, in the Refrigeration Mentor podcast. I want to thank everybody once again for taking the time out of their busy Mondays to come and hang out, learn a little bit about CO2s from the experts from around the world. And this week, we have a legend in the industry who has been doing refrigeration for longer than I've been alive. He's I believe one of the creator helped design the first single screw on the planet. And I've learned a lot about Vilter over the years when I did work at Emerson and Copeland and spent some time with my good friend Jim Dick, learning from him, been down to the Vilter plant, seen their operation there. It's really unbelievable what they have going on. And this product that we're going to talk today, and some of the product they have for CO2 for the industrial space, is game changing. And I'm super excited to learn a little bit more from Jean-Louis. And he's going to dive into a lot of what's going on at Vilter and their CO2 product line. Jean-Louis, welcome to CO2 Monday. How you doing?
Yeah, very good. Thank you, Trevor. My name is Jean-Louis Picouet, and I've been working with for 25 years. I'm director of the R&D department, so taking care of all the development and the lab. And before that, I was working with Single Screw Compressor Inc., SSCI, on the East Coast, the inventor of the single screw, Mr. Bernard Zimmern. Yeah, I worked with him until from 85 to 96, and 96 to 98, more or less took over the company. And after that, I decided to join Vilter to the R&D and continue, the research with Vilter.
Yeah, and I appreciate you taking the time on your busy day to come in and chat with us a little bit about the CO2 product line, because it has evolved immensely over the last few years and even over the last few decades. And I continue to see the single screw get huge traction. When I was with Jim, he taught me a lot about the single screw and how the advantages of it. And I can't wait to hear about the advantages of using it as the screw in CO2 applications, because this is one of the things I've seen, and maybe you've noticed it, is that a lot of the industrial applications have a lot of compressors. So you're going 20, 30, 40 compressors, and this could be the game changer where you don't need that many compressors.
Yes, that's right. So maybe let me start with a little bit of Vilter history. I mean, I'm going to go through fast. So Vilter has been, founded in 1867. So I think right now, I mean, we put like 280. I think we are around like 300 people at Vilter. And I mean, we have, a big factory, and you can read, I mean, we do industrial, gas compression, and anything you can compress, we can compress, more or less. So this is a Vilter factory. So that's a big plant, and we have plenty of room to expand. And we have pretty large lab. I don't remember exactly the size of the lab. Maybe I think the lab is around, maybe 8,000 square feet of lab with different loop, ammonia loop and CO2 loop. I'm going to show you, a few pictures of inside the lab. Vilter has been existing since 1867, and to bypass everything, we have been, doing the receive, because we do receive also, not just a single screw. We do receive from a 2-cylinder to 16-cylinder, like a 2-cylinder for 6, 8, 12, and 16 since 1945. And 1990, Vilter decided to take a license from Zimmern, where I was working with him for the single screw. And we have been doing single screw since 2009. Emerson acquired Vilter, and which was a nice thing, because at the time we had what I call like a small lab. And with Emerson, we were able to invest a lot in the lab for us to be able to test absolutely everything we do. So that was a really nice adder to Vilter. And just recently, I mean, now we are no more Emerson, we are under Copeland. But it didn't change anything for us at Vilter. We are still Vilter, and I think we are still going to be like a Vilter brand, something like that. Didn't decide 100% yet.
Yeah, well, Vilter's a real strong name in the industry. So I've talked to people around the world. They work on Vilter equipment. So it's a good, strong name in the industrial industry.
Yes. I mean, we have been selling, I mean, the headquarters is in Cudahy, Wisconsin, and we have been selling, units and all over the world for a long, long time. So that's why, I mean, the Vilter recipe is like all over the world. And the screw is now all over the world. But that's why, Vilter name is known for his quality and robust and last a long time. So this is, in short, this is what we do. We just don't do, compressor. We do units. That's why, we don't do, like millions of compressor like our sister, company Copeland. Last year, maybe we did, I don't know, maybe 600 compressor, but we put, the unit around, and those units sometimes are like, the size of the small house. So that's, that pretty large, units. And again, we do a lot of gas compression, a lot of heat pump, and now going into the CO2 market. So these are just to show everybody. This is a standard single screw. In case that's, if some of you doesn't know, single screw with 2 gate rotor. And so those 2 gate rotor, if you turn one gate rotor like 180 degrees, you have the same parts. So more or less, we have like 2 compressors in one. And this one shown here, that's what I will call the standard, standard pressure single screw with volume and capacity slide. And we are the only one in the industry to have volume and capacity slide who can be adjusted to all capacity and all capacity and all volume. So even at part load, we can adjust the volume slide from very low volume ratio to very high volume ratio.
And that's one of the biggest difference between a semi-hermetic recip compressor you have to that you can put potentially a drive on compared to the screw where you have these slide valves that can really be dynamic in the amount of capacity you have in a system and flow, right?
Yes, absolutely. Semi-hermetic was where, I work with a semi-hermetic machine, a lot in my past in air conditioning. For me, one of the advantage of the, what we call like open machine is like with one compressor, you can have any type of motor, any kind of horsepower, and you can have any type of gas. With one machine, we can go again from different gas, different mass flow. So that's a big advantage. For us, between natural gas to ammonia and CO2, practically the only part we change will be the mechanical seal, because as that is the O-ring inside the mechanical seal. This is it. The whole internal of the machine, stays the same.
And that's amazing, right? So one part, and now your system can work on with any type of gas or refrigerant. So that's super cool.
Yes. So the next slide, show you single screw is a balanced machine, compared to any other compressor. So again, like I was saying, previously, we have the screw, the single screw in the middle, and we have the 2 gate rotor that compressing the gas on each side. And if you take one side of the gate rotor and you turn it 180 degrees, you'll have exactly the same compression force on both sides. Kind of the same thing, because this is not exactly right here. We have balance loading because we have suction pressure on both sides of the screw. But what is not shown here, we have the shaft. The shaft is coming out of the compressor, so we have some actual force that we need to deal with anyway. But on the standard compressor, the actual force is really minimal. We are going to talk more about that on the high pressure, because that make a difference on the high pressure machine. Because of the balance loading, again, on the standard machine, we have the 15 years bearing warranty on the machine. And when we say 15 years, a compressor can last much, much longer.
And so you have a lot of experience in this. And I know I talked with Jim and learned a lot. So there's a 15-year bearing warranty. With the proper inspections and with the proper service and overhauling, they can last a lot longer, right?
Yes, absolutely, yes.
Can you give an idea on when it's properly serviced, properly maintained, what you've seen over your experience, how long they could last?
We have seen compressor with like 130, 140,000 hours. Even I'm not even just talking about the compressors, the gate rotor also, not just the bearing. The gate rotor can last this long also, because that's one of the things in the past, like people were saying, hey, the gate rotor are in plastic and they wear off, and this is not true. They don't wear off, and they don't wear off just because of the profile that we have on the screw. That's a very special profile that we adjusted over the year. So that's why we don't, the coefficient of friction is very, very low. That's why we don't wear those gate rotor. And this is oil injected machine. So we have lubrication at the same time. If you don't have anything, bad going through the machine, you don't need to change the gate. If you have some, a lot of dirt particle that going through the machine, okay, you will wear off the gate, but if you change the gate, which is easy to do, the compressor go back to square one with exactly the same capacity. This is very rarely that we change the screw. When we change, the screws, the rotor, that's when you have a really big problem.
Super impressive. And compressors, when it doesn't matter, the compressor, if they're maintained, serviced, and looked after, they last a long time. And what I really like about the industrial side, because I work mostly on the commercial side, is that guys need to take it apart. Technicians and people need to take them apart, look at inside them. And this is what I'm trying to get other sides of the industry, especially the commercial side, to do. Look inside them. How do you learn about them? All your experience, and a lot of your experience, was getting and ripping them apart, looking inside. What happened to it? Why did this happen? And you get an idea of how it was functioning. So it's real cool. Thank you.
To show how we progress to this high pressure. Because for us, the high pressure, we have been doing high pressure for a long time because of gas compression. We have roughly 15 plus years that we started with gas compression, higher pressure. So we started, again, the normal housing is like cast iron that we can go up to like 540 PSI. And after that, for gas compression, we went to the ductile housing that we can go up to 750. And right after, we started to go with a steel housing with 1100 PSI. And again, this was for gas compression. We started to think about the HPLD, that high pressure, low displacement compressor. We are thinking, that was for natural gas pipeline, like, around 1500 PSI. But this was back in 2015, 2016, and came, the CO2. And people were, in marketing were starting, what about CO2? Can you go higher than 1500? And we said, yes, we can. So that was more or less the question, how high do you need to go? And the pressure was like, okay, 2000 PSI. And so we changed the design to be able to go to 2000 PSI. That's what the new compressor, what we call HPLD. Again, HPLD is high pressure, low displacement. We called it, low displacement because at the time that was the lowest size single screw that we ever developed at Vilter. Again, so we designed that from natural gas. In between, we went into also heat pump, ammonia heat pump, and after, the CO2. Because ammonia and natural gas, the property are almost the same. So that's for mass flow and everything. So that's kind of the same. So that for us, again, the only thing we had to change that was, the chassis. So very easy for us. We don't have to deal with, again, semi-hermetic, different horsepower motor, and different valve for the receipt, because we know that in gas compression, the receipts, they don't like, to have huge variation of suction. With the same compressor, you go to like 50 PSI suction to 600 PSI suction. This will be the same design. So that's a really flexible machine.
That's unbelievable. That is unbelievable. Where Copeland, you would have a dozen different compressors.
Yes. So the next slide. So this is the HPLD, the latest compressor. Again, that's a 2000 PSI machine. So this one, I have a couple of cut view, the early cut view. I'm not going to show you the latest cut view. But this one has no slide because we decided to go without capacity control since that was VFD. So volume ratio is more or less like built-in, on order. We have the housing on the shelf, and let's say if you order a machine for like 3-to-1, 4-to-1, we cut the port for the ratio. But we cut the port, you still have the flexibility. Let's say if we cut the port from like 3-to-1 pressure ratio, you still be okay to use it for like, let's say for 1.5 to 5 before you have some, power loss, so something like that. Again, so this was designed just to handle, pressure. So this machine, maybe I can jump. More or less we can go short to 2000 PSI. So that's 2000 PSI. We can go, like 1000 PSI differential pressure. My maximum suction, we can certainly go up to around like 1000 PSI. Shaft horsepower, we can go up to 900 horsepower on a single compressor.
You say 900 horsepower?
900 horsepower, yes.
Wow. So right now with this design here, is there only one design, and we may get into this where you can change that capacity because you said you can go from a 1.5 to a 5. What can this potentially replace that's out there right now in size of like racks? Because what I'm seeing in industrial is where, like I said earlier, you got 25 compressors, a 30 compressor. What will this potentially replace, and the advantages for like contractors out there or even end users instead of having 47 compressors or whatever it is to this? Like, how can we compare it?
I mean, to compare, I mean, this will be to compare, at specific suction and discharge. This will depend, again, of the suction discharge. But just to give you an example, maybe I can show you this slide here. So this slide here, I mean, that was on LinkedIn. That was a unit that we took to the IIR show. And right now that's running, every day in our lab. So this unit, for example, is a 160 machine. So again, the HPLD, we go from 128 CFM to 243 CFM at 3600. But we can go up to 4300 RPM. So let's say the largest one will be equivalent to like a 290 CFM machine. Even if you compare, I think Doreen came up with 60 CFM, the latest one. I mean, I don't think they're in production. If we just talk CFM, no tonnage, so this would be like 4 times the largest one that you can find in the market right now.
Yeah. So that makes a big deal, especially for like big industrial plants that are moving towards CO2, where now you can have maybe 2 or 3 of these compressors and one as a redundant compressor, for an example.
For us, we are not looking for the small tonnage because this we cannot compete. Because this is, industrial package to compete against commercial. So if you just put our, smallest machine against 4 small any compressor, for us it would be hard to compete. We are looking more like industrial and, larger size, let's say like around like 400 ton and above. That we really will be above, everybody. Again, because this is industrial, you get the single screw. And then we have some, in the natural gas. We started that. Maybe I can jump. I'm sorry, I'm jumping between.
No, it's good. I love this. This is way better.
Yeah, so here, so you see this, we started the first prototype in 2016. So we have some, running in the field for like 4+ years. And, in the high pressure, natural gas. The first one we installed, that was in California, is still running. And we didn't do anything to the machine yet. That's just to say the single screw, the robust design, and that's here to last a long time. We are not like some other compressors that you need to rebuild like every year or something like that. When we said this is going to last, this is going to last. For bearing life, okay, we cannot go to the 15 years. I mean, this is the goal. I will say we can go the 15 years depending on what condition. But for bearing life, maximum pressure, let's say if you had a compressor, because we went to, the maximum of the envelope. If you go to the compressor with a 2000 PSI, discharge, 1000 PSI suction, if it was possible, with 900 horsepower, the compressor can last up to 10 years. Because again, we changed the internal design is not like a standard, single screw. Even no other single screw in the world is like that. Even the other single screw licensee like Daikin, McQuay, all the other licensee. So this one, we have a special internal design to more or less what we call like reverse loading the force. Because of that, we can go up to those kind of pressure the 10 years. Because again, I mean, we say, balanced loading, but again, you have the shaft, coming out of the compressor. So when you have, and the shaft size is 2.5 inch. So when you have a suction pressure of 1000 PSI, you have 1000 PSI trying to push, the shaft out. So that's a lot of load. But we have, again, some internal designs that we can reverse some of the load. So I can show, again, this one is a cut view, but that's the early one. So That's not like what we have right now, but just to show you a normal single screw, we have 2 bearings. So this one, we have 3 bearings. Again, that's because of the 1000 PSI differential and 1000 PSI suction. So we had to add third bearing. And again, I mean, this is completely different now anyway.
So technicians and contractors out there that have been working on Vilters in the field and they come up to look at one of these ones, will they have any issues working on this type of Vilter screw compared to the ones that ran on HFCs?
No, absolutely not. They just need to, I mean, to contact us and we show them the difference. I mean, that's the same. I mean, that's one rotor and 2 gate rotor, but that's the way to assemble them. And that's, different. And again, different parts to assemble inside the machine. But this one is even, I would say, almost easier to assemble than the standard one because we don't have the slide. So we have a less part movement compared to the standard, screws.
Yeah, and that's huge in itself there because I did hear of technicians in the field sliding them in or the parallel slides and jamming them and denting them. And now if you don't have that, that is reducing the complexity. Amazing.
Yes, absolutely. Yes. I mean, that's one of the reasons we did it without slide because of the internal force. And since we do that, this one was born with natural gas, and natural gas, that's not clean gas because that's an open system, not closed system. So sometimes you have, let's say, some stuff going into the machine. So when you have less part in movement, that's better off for the compressor.
Yeah, and that's for sure. Any refrigeration system needs to be clean, but in the natural gas space, it doesn't come out clean. So you got a lot of filtering and a lot of cleaning up. But you designed the system, which is real cool, to hopefully reduce that. There should be nothing in there, but
yes. And again, I mean, also one of the advantage of the single screw compared to, I would say, the other compressor, that's the way the compression process happened. I always say a story to the marketing people. A long time ago, I was on the West Coast. I saw a very old coffee grinder. So to say that the coffee grinder was a twin screw. That was, 2 screws grinding coffee. If you try to grind coffee with a single screw, this will be impossible. Because, the way that the gate rotor with the screw that rotates is like a broom effect. So if you put any, let's say, particle coffee into the single screw, this will be pushed into the discharge, the compressor, without doing any damage. I mean, that's why also, I mean, that because of this, that the single screw does not lose capacity over time. Capacity, let's say, efficiency at the end, COP, on the heat pump, because we had some customer in Europe, they were surprised and the COP was flat because they were used to COP dropping, over time. Because of that, we don't have, like some other compressor, you have the tip seal, for example, and you lose the tip seal over time because of the particle getting around the screw. And we don't have that. Does not happen. Because again, I mean, all particles are pushed away to the discharge area and our COP, stay flat.
I think that's something that I've learned as well because I didn't work much in industrial, but when I was in some of these Vilter trainings, one of the questions that a lot of the industrial technicians was saying, well, they wear out, those blades wear out and damage over time. Well, they could get damaged, but they don't wear out per se. They get damaged where there's wear, but they don't wear out.
Yes, and if for any reason they wear out, first you need to find out why to fix your problem, but you can install some new ones and you are back to square one because again, the rotor does not wear. If you have some wear on the gate rotor, you have major problem somewhere else.
Yeah, yeah, exactly. You're gonna have to fix that. One good thing about the industrial stuff, when you do an overhaul, you get to look at the parts, and over time, you should be able to start recognizing scrapes or markings on them from a new one to what is damaged. And really, at the end of the day, it's our job as refrigeration professionals to figure out what caused that. Was it liquid refrigerant? Was it overheat? Was it one of these mechanical issues?
Yes.
So you've been testing these CO2 compressors for years and years, these high pressure, low displacement single screw. What is one of the things that have surprised you in all this testing and running over the last few years?
Before, we were doing high pressure ammonia, high suction pressure, but the mass flow is different because of the CO2, the mass flow is double or triple. One of the things that we found, because we were doing already really good with ammonia heat pump with high suction, the efficiency was better. Looks like the screw like high suction, high mass flow. That's why we're able to go to very high 500-600 psi CO2 suction pressure, because the mass flow is like really, really high, but the efficiency, we are still okay on the efficiency. One of the surprises that we had when we first started to test the CO2 on a single screw.
That's a good surprise.
Even when I think about my past, when I started my single screw career, I guess that 300 psi was very high pressure for discharge pressure. And now we are talking, 6, 7, even more psi for suction pressure. So that's the evolution, I guess.
Yeah. And the thing is, you've been working on it, seeing it for a long time, and I keep hearing about, oh, they are higher pressures. They are, but we need to invest some time into training, education, learn about CO2 because it is different, and the safety factors, but it's no different than walking into an ammonia plant. You need to understand your safety procedures. And with CO2, there's safety procedures as well. As long as you train yourself, get some training involved, it's going to make it so much easier to work on these systems here.
Yes, like you just said, with ammonia or CO2, you need to respect what you work with and understand what's happening, inside the pipe. That's a big number one, and that's what we teach also here in the lab, because a lab is still a very dangerous place to be. Even in our lab now, we have, ammonia, CO2, and, everything, high pressure when we run. So that you need to respect that and follow all the safety. Emerson in the past and Copeland and us also, Vilter, we are very aware of safety, and this is the number one thing we look at, every time we start our lab every morning.
Yeah. But that's important in our industry, and it doesn't matter if you're working in industrial, commercial, residential. We do need to understand the safety side, understand the codes, and make sure that we're abiding by it, and do not cut corners. This is important. We're a highly skilled trade, and it's important to be safe. You always want to go home to see your family at night, and you need to be safe. And it doesn't matter what refrigerants in the system. We deal with high voltage. We deal with chemicals. Be safe out there. That's what I love about working with manufacturers like Vilter and Copeland and all the other ones out there, is that you guys are very in tune with the safety procedures and why it's so important. So good on you. So your bigger surprise was kind of the efficiency on it. Where are you seeing this? Where do you see this being applied in the application? Because we're doing this now, and I know even when I was at Copeland here in Canada, they were getting calls for this compressor years ago. So where are you going to see the biggest market for this? Are you going to see it in the heat pump application? Are you going to see it in the refrigeration application? Where do you kind of feel where it's going to fit in the market and where you're going to see the biggest growth for this compressor?
Right now, there's the biggest growth we have with this family of compressors, that natural gas. Because we have been doing that, because natural gas, you have different stage, 2, 3, 4 stage. And we were always missing, the last stage where you have to use, high pressure receipt. And now with the HPLD, we can use that for the last stage. And again, we have been doing that for like 4 or 5 years, even more. So right now, that's number one. But again, since this was developed for high pressure, and we have been doing, heat pump, ammonia heat pump, because that's very easy to do, even easier than natural gas, because again, that's a closed system, so clean system. So those will last a very, very long time. And the CO2, which is new, new and not new, as you know, in Canada, we have Hydro-Québec, who has been running, CO2 Transcritical for almost 2 years now, a year and a half, 2 years. I don't know how many hours they have, maybe like 14,000 hours they have on it on one machine, the 222 CFM size. And over there, I think we have a 700 horsepower motor on this one, and has been doing really, really well. And again, we did that with Hydro-Québec, and thank you for them doing that with us, because that was a huge development for everybody, and a lot of work, a lot of people. That's just incredible. But to arrive to where we are today with a nice product, and that can change the industry, for heat pump and CO2 high pressure.
Yeah, definitely. So right now at this point, for any CO2 heat pumps or CO2 refrigeration application, can people start ordering this equipment from you? If they want to get one of these, do you have them available? Is there a massive timeline on them?
Means the compressor is there, okay? Yes, the compressor is there, but we are, we are finishing it, the design on the units, the several compressor unit. I mean, we have the two compressor units already, working, but we are, finalizing everything. That's why we tested, and more or less, this is to test, the program software, how to handle two compressor, one compressor, and so we are, doing the fine tuning right now of the software. Year, like by the end of the summer of this year. So, but late summer, let's say, late summer. We can do, because, I mean, as you say, I mean, CO2, you have transcritical and subcritical. So, but right now we can sell a subcritical if anybody wants some subcritical. But the transcritical, multi-compressor will be late summer 2023.
Yeah. So that's not far away. Summer is very, it's going to be here just like that. And you'll have more time on these applications you already have out there. There'll be more experience. I know for sure I'm getting messages already. People are looking for them right now. But testing takes time, and you want to do it right, and especially you want to make sure it works and you stand by what you guys say when they're out there and running, right? Because you tested it.
Yeah, and right now this is like unit testing. I mean, right now that we see we don't have oil pump, for example, that's running without oil pump. So that's all the fine tuning. We have some other way to send the oil, that's a patented, solution. And we are looking at oil management. And again, I mean, all on the unit side. Compressor, we are done with the compressor. Compressor is a known, unit. And so right now we are concentrating on the unit and management of unit and everything.
Oh, that's amazing. That is amazing. I know there's lots of people excited about this unit. What else can you share with us about your CO2 units?
Okay, this was the lab, because this is the lab, now. So you can see we have two loop in the back. So the two loop in the back are here. So this one, this is where we started to test the high pressure, for natural gas and heat pump ammonia up to 1350 psi. So when we decided to go CO2, we converted this unit here, the one in the front, to full CO2. This one, we use this one to develop the CO2 compressor, more or less, to find out what we needed to do, and then we didn't do too much, let's say, but we wanted to test to make sure that what we put on paper, that what we were, getting, after testing. After, when we built last year the unit with the two CO2 compressor, we moved away this unit, and we installed the one from the IR show to have a full-blown, testing. That's how is the lab. So we have, the CO2 unit in the front, and we have the two, ammonia, loop, because before we had 3 ammonia loops, so now we have 2 plus 1 CO2. And the ammonia loop, again, we can test up to 1800 horsepower. On the ammonia, right now, we can go up to 900 psi, and we can do 2-stage also, because we can work, the loop, together. So again, I mean, the lab is really, everybody is, impressed when they go into our lab, because this doesn't give you a scale, because this is huge, that's a big lab, and again, we can test everything we do, so that's really nice.
It looks like a fun playground. That's what it looks like.
You need to come see us at some time when you are in the area.
I definitely have to, because one thing that I love about manufacturers like Vilter, you're always testing stuff, but you're always willing to, when you train someone, you show them the equipment, to test the equipment. Because I know I've been there a long time ago now, 5, 6 years ago, but just the growth and the continued advancement that you guys are trying to do, just even this CO2 section, which is amazing to see. And what for me, I always love to go check out manufactured equipment, how they build it, being very curious about that. Because even the screw, like the industrial side, that was not what I've done in the field. But anytime I got to pull apart a screw, or anytime I got to see something about refrigeration, made me very curious. And going to manufacturers just like this lab, would be so fun, just to ask a lot of questions, because that's what it's all about, learning, growing your knowledge.
yeah, learning every day. And it's again, thank you for having me because I was really excited when you asked me, to speak because I've been doing single screw for a long time, and still the single screw is not known into the industry.
We're gonna get it more known for sure. That I
Yeah.
promise you there, and I'll definitely have you on again. We'll dive into some more technical stuff. Jean-Louis, how can people get a hold of you, get a hold of Vilter, if they want to find out more about this single CO2 single screw?
Okay, this one, I mean, you can contact me. That my name, Jean-Louis.Picouet at now the case this is Copeland, no more Emerson at Copeland.com. And here I got some link, but you can go to Vilter.com and you'll find, I mean, everything on the, heat pump, the natural gas, CO2, what we did. And because, I mean, we started to do CO2 subcritical. We have several units, in Europe, and has been working, really well. Because again, subcritical for us now is low pressure because that is a 600 and 700 PSI range. So
Yeah, low pressure, 600 psi. I love it. So I'll get these links from you and I'll put them in the show notes. I really appreciate you taking the time to do this, to kind of show us what is coming, because I know there's a lot of people excited about this compressor and these ones, and I want to thank you for taking the time.
no, absolutely. Really enjoy to talk to everybody here. For everybody, don't hesitate, to contact me or contact, Vilter.com. And if you have any question, and please come, visit us to see what we really do.
Yeah, I highly recommend that. They do some amazing training down there, and it's top notch. I know I've been there for the training, so very cool that you spent some time with us. I really appreciate everyone taking the time to listen to us today, learn a little bit about the Vilter single screw compressor, and I want to thank everyone who's listened on the podcast. Please share this on your Instagram stories. Share this with someone who wants to learn a little bit more about this industrial CO2 compressor and where it's going to go, because I know next year when we have this conversation, there's going to be more in the field. They're going to be growing, and I'm super excited about this. Once again, Jean-Louis, thank you so much, and we'll see you at the next CO2 Monday.
Yeah. Thank you for having me. Thank you, everybody.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.